So today our topic is moment of a force. When you turn on the tap, you create a turning effect. When you move your hands round, the tap opens. Right here, there is a turning effect that ensures that the tap is opened. Another example where you have moments is when you try to use a force to open the cap of a bottle. So we all use a bottle opener or an opener. So you push it up and then the cap is removed. So there is a turning effect. There's a turning effect that opens the cap. Now this is the third example. When you ride a bicycle, this is your foot. Your foot pushes the pedal forward, thereby creating a turning effect. So in these three examples, there is a turning effect. There is a turning effect. Now, this turning effect is what is known as the moment of a force. Let us define what the moment of a force is. So, the moment of a force about a point or axis C is the turning effect of the force about that point. It is equal to the product of the force and the perpendicular distance of its line of action from the point C. So if we want to demonstrate moment, we would need to have a meter rule, and we have our axis, which is also known as the pivot or a knife edge. It's a knife edge. So this is what we call the pivot or the knife edge, or we take it as our axis. So this sits on a surface, and then we get a meter rule. So we do the arrangement in such a way that the pivot is named as C. So we can see it here, moment of a force. So when we attach a force F at the side of C, remember C is our pivot or the knife or the axis. Now the distance between the line of force of F and C is known as the perpendicular distance. You can see that F is perpendicular to C. So the moment of this force, or the turning effect that this force would make, is going to be the force times the perpendicular distance. Can you see it? So it's F times D would give you the turning effect, the moment of this force. Now, it is not all the time that the force, the line of force, is perpendicular to the pivot. Look at this example here. You can see here that the line of force is not perpendicular to C. You see that this line is at an angle theta to C. So when the force is applied in such a way that the line of force is not perpendicular to C, this is what you do. The distance that you would use in calculating the moment, the turning effect of that force, is going to change, and it will change to F times this distance here. When the line of force is projected, and then the line from the axis or the pivot or the knife edge is also projected, we can see that they stand at angle 90 to each other right here. So this distance would be the perpendicular distance that you require to get the moment of the force F. So in this diagram, you can see that the perpendicular is d sine theta. Now you may ask me, how did you get d sine theta? You would have to have the knowledge of resolution of vectors to be able to understand why the perpendicular distance here is d sine theta. But for the sake of this topic, just know that the perpendicular distance is d sine theta. If you have any problem with vector resolution, please do not hesitate to put in the comments so that I can send you that video that explains the resolution of vectors. So to calculate the moment of this force, it's going to be F times d sine theta. So we can see that right here, F times d sine theta, because d sine theta is now our perpendicular distance. So let me go over what we have done again today. We have discussed that the topic is moment of force, of a force, and we defined moment as the moment of a force about a point or axis C is the turning effect of the force about that point. It is equal to the product of the force and the perpendicular distance of its line of action from point C. So what this means is moment is equals to force times perpendicular distance of pivot or the line of action of the force. Now we further explain that when you have a force that is applied perpendicularly to your pivot C, then the distance between the force and C is d, and that d is your perpendicular distance, is the distance that is referred to here. So to find the moment, the turning effect of this force F, all you have to do is multiply the force times the perpendicular distance, which is F times d. Will give you the moment. It will give you the turning effect of this force. Now, when you go to a second diagram, you would see that it's not always that the force, the line of force, is perpendicular to the axis C. So when you have a situation where the force is not perpendicular, what you do is to extend the line of force, you extend it, and then you also extend the line from the axis. Wherever they meet, they would meet at an angle 90. So therefore, making this side our perpendicular distance. So to find the moment of this force, to find the turning effect of this type of force that is placed in a manner that is not perpendicular to C, we are going to say the moment is F times d sine theta. So this gives us the moment of this force. So from this explanation, I hope you understand what the moment of a force is.